Okay, so we're diving into a philosophy of software design today.
Yeah.
And this isn't like your typical dry technical book, right?
Definitely not.
John Ousterhout, he really breaks down this idea of how do we build things that are less of a headache, to maintain and work with.
Right.
And it's not even just about software,
Yeah,
right?
that.
I mean, we're talking websites, teams, even planning a trip. Like these ideas, you can kind of use them
Oh, absolutely.
for anything that's got some complexity to it.
Yeah.
So our goal today is to give you sort of the highlights of the entire book. So
Buckle up.
yeah, buckle up. So one of the things that's really cool about this book is it's not just like theoretical fluff.
No, not a...
This is from someone who's been in the trenches, right?
Yeah, John Ousterhout has been there. He's faced every single design nightmare that he writes about.
Yeah, so these aren't just ideas. These are like battle-tested strategy.
Battle-tested, exactly.
It's like having a mentor,
Yeah.
sharing all their wisdom, but you don't have to buy them coffee.
Exactly. And the beauty of it is that means for you, you're getting actionable advice, not just high-level concepts.
Right, right. Okay, so let's jump in. Why is good software design so important in the first place?
Okay.
And how do these ideas, apply to other fields?
So think about it. Software is inherently more complex than, say, like building a bridge, right?
Okay.
You can't predict every consequence of a design decision before you actually build it.
Right.
And unlike a bridge, software constantly evolves, so those choices you make early on can really haunt you later.
That's so true. I mean, it's like with a bridge, you can't just add another lane in the middle of construction.
Right.
But in software, that kind of stuff happens all the time.
All the time. And that's exactly why he talks about this concept of incremental development, which is like the idea that design is this ongoing process.
Okay.
Not a one-time thing.
So you're constantly evaluating, refining, redesigning as you go.
Exactly.
Got it. So it's not just about that initial structure. It's about how adaptable that structure is over time.
Yeah, exactly.
Okay, I like that. So Ousterhout, he talks about these red flags.
Yes.
What are those and why are they so important?
These are signs that a design is getting more complicated than it needs to be.
Oh.
So it's kind of like an early warning system for complexity.
So we should be looking for these like all the time, not just when things start to go wrong.
Absolutely. And in fact, he really emphasizes this idea of using the book as part of code reviews, which I think is brilliant.
Oh, interesting.
Yeah, it's often easier to spot those design flaws in someone else's work.
Right.
And this gives you a framework to do that in a really constructive way.
Yeah, that's super helpful. It's like having a shared language, right?
Exactly.
To talk about good design.
Exactly.
Okay, cool. So we kind of want to create better systems, obviously.
Right.
We got to understand the enemy, right?
The enemy. Complexity. Yeah. So what exactly is it? How do we know when it's creeping in?
Yeah. I mean, everyone kind of has this intuitive sense of like, oh, this feels complex.
Yeah.
But I'd love to have a more concrete definition, especially in the software world.
Yeah, absolutely. So it's not just about the lines of code, right?
Okay.
It's more about the effort that it takes to understand and modify a system. And
Right.
he talks about 3 key symptoms that should send those alarm bells ringing, right?
Yeah.
So the first one is change amplification.
Change amplification. Okay.
Yeah, this is when a small change ripples out, and it requires modifications in a lot of different places.
Oh, I've seen that. Like when you change one tiny thing on a website and it breaks something totally unrelated.
Exactly.
Yeah.
Then you have cognitive load, which is the mental gymnastics that developers have to do to work on the system.
Okay.
So if you have to hold a ton of information in your head just to make a simple change, that's a sign of complexity.
Oh, yeah. It's like trying to solve a puzzle where the pieces keep changing shape.
Right.
No wonder developers pull their hair out. Okay, so we got change amplification, we got cognitive load. What's number 3?
Unknowns, those shadowy areas where it's not clear what will happen if you make a change.
Okay.
You're basically fumbling in the dark, hoping you don't break something critical.
So complexity can manifest in all these, like, sneaky ways. They go beyond just, like, lots of code.
Right. And here's the thing. Complexity accumulates slowly, like clutter.
Oh, yeah.
You might not even notice it until you're like knee-deep in this tangled mess.
Okay, so we've defined complexity. We know what it looks like.
Yeah.
What's the game plan?
Okay, so Ousterhout calls this strategic programming.
Strategic programming.
Shifting your mindset from just getting the code to work
Okay.
to actually building something that's going to evolve gracefully over time.
So it's less about putting out fires and more about fireproofing the building in the first place, right?
Exactly. And it means being wary of those quick and dirty solutions that create more complexity in the long run.
Oh, yeah, we've all been there.
Absolutely, especially when deadlines are looming.
Yeah.
But prioritizing future extensions and making that code base easier to work with later on is going to save you countless headaches.
So it's about setting yourself up for success.
Yeah.
Not just today, but for months or even years to come.
Exactly.
Okay. Now, you mentioned this idea earlier of deep modules.
Right.
Tell me more about those.
Okay, so think of modules as building blocks,
Okay.
right? They can be classes, subsystems, network services, really any part of a system.
Right.
And a deep module has a simple interface, but it hides a lot of complexity behind the scenes.
Oh, okay. So it's like using a smartphone, right?
Exactly.
You don't need to understand how the processor works to make a call or send a text.
Exactly, and that's powerful, right?
Yeah.
Because it means you can build on top of these complex systems without having to be overwhelmed by the details.
Right, right.
Think of things like the Unix I/O interface or garbage collectors. Those are great examples of deep modules. Right.
So even though they're handling all this like complicated stuff behind the scenes, users just see this like simple way to interact with it.
Exactly. And the key is to minimize the amount of information that someone needs to know to effectively use that module.
Okay.
Right. So the less they have to keep in their head, the better.
That makes a lot of sense.
Yeah.
Now, what about when modules aren't deep?
Yeah. So he calls those shallow modules.
Okay.
And they're basically the opposite, right?
Okay.
The interface is complex compared to what they actually do.
Okay.
So they don't help much with managing complexity because you're still exposed to all the messy details.
It's like having a smartphone where you need to like reprogram the antenna every time you want to make a call.
Exactly.
Yeah.
Or even something as simple as a linked list class.
Okay.
Right?
Yeah.
It's not very complex, so the abstraction doesn't actually hide much.
Right. Got it. Got it. You mentioned the Unix I/O interface earlier.
Yeah.
What makes that like such a shining example of a deep module?
So it's deceptively simple. Like, you boil it down, it's a handful of basic operations. Read, write, open, close.
Okay, right.
That's pretty much it, right?
Yeah.
But behind that simplicity, it's this whole universe of intricate mechanisms, right? How files are stored on disk,
Right.
how permissions work, how the system handles simultaneous access, and so on.
It's like you had this team of like invisible assistants,
Yeah,
taking
yeah.
care of all that complicated stuff.
Totally.
So you can focus on the tasks, the important stuff.
Exactly. Deep modules let you build on this powerful foundation without getting lost in the nitty-gritty.
Okay, so I'm starting to see the power of these deep modules.
Yeah.
How do we actually go about designing them?
Okay, so one of the most important principles is this idea of information hiding.
Information hiding. Okay.
So this is about minimizing the dependencies between modules by controlling what information they're allowed to know about each other.
Oh, okay. So it's like setting boundaries.
Exactly.
Each part of the system should kind of like mind its own business
Yeah.
and not interfere with the others.
Exactly. Now, if information starts leaking between modules, that's when you get into a tangled mess.
Yeah.
He calls that information leakage.
Information leakage. Okay.
That's a big red flag to watch out for.
Do you have an example of that from the book?
Yeah, he talks about this student project where there were separate classes for receiving and parsing HTTP requests.
Oh.
Seems like a reasonable split. Right.
Yeah.
But it led to information leakage.
Why? Why is that?
Because you can't actually read an HTTP request without parsing at least part of it.
Oh, okay.
Right. You need to know, like, the request length, which is in the header.
Right.
So both classes need to understand that structure, which just created duplication and complexity.
Ah, I see. So by trying to be too separated, they actually made it like more complex.
Exactly. And the fix was to combine them into a single class that handles both the reading and the parsing.
Okay.
That way, all the logic about the format's in one place.
So sometimes a bigger class can actually be a cleaner design. Okay. So, you talked about like the Unix I/O interface.
Right.
You talked about information hiding.
Yeah.
What other strategies does Ousterhout recommend for fighting complexity?
Another big one is favoring general-purpose modules over special-purpose ones.
Okay. That seems counterintuitive.
Yeah.
Wouldn't it be more efficient to build something specifically for your needs?
You would think so, but building for those very specific needs often leads to more complex interfaces.
Okay.
And more information leakage down the line.
So you try to be like hyper efficient in the short term
Yeah.
And you end up creating more work for yourself later.
Exactly. And what's interesting is even if you only end up using that general purpose module for its original purpose, the simplicity benefit still outweighs the potential for unused functionality.
It's like having a multi-tool, right?
Yeah.
Even if you only use the screwdriver, it's still more convenient than carrying around a whole toolbox.
Exactly. Perfect analogy.
Okay, that makes sense. So, do you have an example of like where this plays out?
Yeah, he gives this example from another student project where they were building a text editor.
Oh.
And they decided to specialize their text editor class with a bunch of methods for specific UI actions.
Okay, that seems reasonable.
Yeah, things like deleting characters, inserting text, scrolling,
Seems like a good way to organize it.
You would think so, but those methods were all shallow. So they didn't really hide much complexity.
Right.
And they ended up with all these methods, each with their own set of parameters.
Oh, geez.
Which creates this huge cognitive load for anyone working on either the UI or the text editor.
Yeah, so it's like having a text editor with a million buttons, each one with like a really specific function.
Exactly. A classic example of how specializing can actually backfire.
Okay. Okay, I'm starting to see the light here.
So,
Deep modules, information hiding, favoring general purpose designs. This is all about taming complexity.
right.
What about comments?
Comments.
Aren't those just a way to explain bad code?
Yeah, that's a common misconception, actually.
Okay.
Ousterhout argues that comments are crucial design tools for managing complexity.
Hold on, wait. Are you saying comments are more than just like explanations?
Yes.
They can help shape the design itself.
Absolutely. They can reduce all three of those symptoms of complexity we talked about. Change, amplification, cognitive load, and unknown unknowns.
Wow, that's a pretty bold claim.
It is.
How do comments achieve that?
They help capture information that's not obvious from just reading the code itself.
Okay.
They kind of complete the abstraction.
Okay.
Right.
They hide the implementation details, and they clarify what the module does and how to use it. So comments are like the bridge between the high-level idea and like the low-level implementation.
Exactly.
Okay. Now, Ousterhout, he has this kind of radical idea about when you should write comments.
He does.
What is that?
Write them first.
Before you write any code.
Yes.
You're telling me to write comments about code that doesn't even exist yet.
Think about it. It forces you to think about the design at a higher level before you get into the nitty-gritty.
Okay.
You're essentially creating a blueprint, outlining the structure and functionality before you write a single line of code.
Okay, yeah. It's like writing an outline for an essay.
Exactly.
You figure out your main points before you start writing the paragraphs.
Exactly. And it makes documentation an integral part of the design process, not just something you tack on at the end.
Right. That makes a lot of sense.
Yeah.
Okay, but writing comments can feel like such a chore sometimes.
It can.
How do we make sure they're actually helpful?
Right.
And not just adding to the clutter?
So focus on the things that aren't immediately obvious from reading the code.
Okay.
Right.
So don't just repeat what the code is doing.
Exactly.
Add a layer of, like, insight.
Yeah. So instead of saying, this line checks if the file exists, you might say something like, we need to check if the file exists because deleting it would corrupt the user's profile.
Okay, that makes a lot more sense, yeah.
Right. So you're providing context. You're helping the reader understand the why behind the what.
Got it.
That's what makes comments so valuable.
This is really making me rethink comments.
Good.
But what about when you're not writing, like, brand new code from scratch?
Right.
How do these principles apply to modifying existing code?
So you want to stay strategic even when you're making small changes.
Okay.
Don't just slap on a quick fix.
Right.
Take the opportunity to actually improve the design even in a small way.
So refactor.
Exactly. Resist the urge to just hack things together.
Yeah.
And really try to make the code cleaner and more maintainable.
Now, refactoring can be time-consuming.
It can.
How do we know when it's worth it?
So he talks about refactoring opportunities, and these are moments when you're already working on a piece of code.
Okay.
And you see a chance to make a small improvement to the overall design.
Got it.
So it's kind of like a 2-for-1 deal, right?
Right.
You're fixing the immediate issue, but you're also making the code base a little bit better in the process.
So it's like small, consistent efforts that add up over time.
Exactly.
Yeah.
Like compound interest for software.
Exactly. I like that. Now, when you're modifying existing code, comments become even more crucial.
They do.
Why is that?
Because anytime you change code, you risk making the existing comments inaccurate.
Right.
It's really easy to forget to update the comments when you're focused on fixing the code.
Yeah, you're in the zone. You're just trying to get it done.
Right. And inaccurate comments are worse than no comments at all.
Yeah, because they can actually mislead people. Right.
Exactly. It erodes trust in the documentation.
Okay, so how do we combat, like, comment decay?
So, 2 main rules. Always update the comments when you modify the code.
Okay.
And keep the comments as close as possible to the code they describe.
Okay.
That makes them easier to find and maintain.
Keep it organized, keep it coupled.
Exactly.
Like it. Okay, so this is all about, making code more readable, understandable. Are there other things we can do beyond just comments?
Absolutely. So one thing he talks about is using white space effectively.
White space. You mean like spaces and line breaks?
Yeah, exactly. The way you format your code can have a huge impact on readability,
Okay.
right? If you just cram everything together, it becomes this dense wall of text.
Yeah, it's like reading an essay with no paragraphs.
Exactly. Use white space to group related elements, to separate sections, to make the structure more visually appealing.
So it's not just about aesthetics. It's actually about conveying meaning.
Exactly. White space can communicate the structure.
Okay, cool. Any other like formatting tips or things to watch out for?
Yeah, he talks about these generic containers.
Generic containers.
Yeah, which are data structures that can hold any type of data.
Oh, like arrays or lists where you just like throw in whatever you want.
Exactly. And they're really convenient, but they can lead to unclear code.
Okay.
And the reason is that the elements inside often have generic names like get key or get value, which doesn't tell you anything about what the data actually represents.
It's like having a box labeled stuff.
Right.
You have no idea what's in there.
Exactly. So whenever possible, use more specific data structures.
Okay.
Ones that convey meaning.
Okay.
And the last one is writing code that doesn't violate the reader's expectations.
Okay. How do we do that?
So follow conventions, right?
Okay.
Make sure your code behaves in a way that people would naturally expect.
Okay.
And if you're doing something unusual, document it clearly.
Okay. So it's about anticipating how someone else is going to interpret your code.
Right.
And making sure it's like as intuitive as possible.
Exactly. This whole reader-centric approach is key to good design.
Okay. So far we've mostly been talking about like procedural programming.
Yeah.
How do all these principles translate to like object-oriented programming?
Okay, so object-oriented programming, or OOP, it can be a powerful tool for managing complexity, but it's not a magic solution.
Okay, so just using objects doesn't guarantee a good design.
Right, it gives you all these mechanisms like encapsulation, inheritance, polymorphism,
Right.
which are great tools for building modular and reusable systems.
Right.
But it's still possible to create shallow classes, complex interfaces, and expose implementation details, even within an object-oriented framework.
It's like having a set of like fancy power tools.
Yeah.
Right. They can help you build amazing things, but you can also just create a bigger mess if you're not careful.
Exactly. The principles of good design still apply regardless of what paradigm you're using.
So it's not about the tools themselves, it's about how you use them.
Exactly.
Okay, so can you give an example of that, like in the OOP world?
Yeah, so you might have a class with a bunch of public instance variables.
Okay, so anyone can access and modify the data, right?
Exactly.
Okay.
Which violates that principle of information hiding.
Right.
We want to keep the internal workings of our objects hidden
Okay.
behind a well-defined interface.
So even within OOP, it's about making like strategic design choices, not just like blindly applying the concepts.
Right, and that kind of leads into the whole world of design patterns.
Oh yeah, design patterns. I've heard of those, but I'm not sure I fully understand how they work.
So think of them as pre-packaged wisdom.
Oh, okay.
From experienced designers, right?
Okay.
They offer you these proven approaches for structuring your code
Okay.
and for managing complexity in specific situations.
So it's like having a toolbox full of specialized tools that you can use for specific tasks.
Exactly, but there's a risk of overusing them, right?
Okay.
Not every problem needs a design pattern.
Right.
Sometimes a simple custom solution is better.
So don't try to force them in where they don't belong.
Exactly. More patterns does not equal a better design.
Okay, that makes sense. So we've got OOP, we got design patterns, this overarching goal of avoiding complexity.
Yeah.
What about testing?
Testing is essential.
Okay.
And it actually plays a big role in managing complexity as well.
Oh, okay. How so?
Because having that comprehensive set of tests gives you the confidence to make changes without worrying about breaking things.
It's like having a safety net.
Yeah.
So you can try new things and not be afraid of like catastrophic failure.
Exactly. And you know there are different types of tests, each with its own purpose.
Right.
So, for example, unit tests validate the functionality of individual units of code.
Like a method.
Like a method, right? You're
Right.
making sure all the individual parts of your machine work before you assemble the whole thing.
Okay, got it. Then you have system tests, right?
System tests, right, which
Oh.
verify that all the components work together correctly, so you take the whole machine for a test drive.
Okay, got it. So both of those help catch errors,
Yeah.
early on.
Exactly. And that prevents them from snowballing into these bigger problems later, which is key to managing complexity.
Right, right. Okay, now what about test-driven development?
TDD.
Right, where you write the test before you write the code.
Right.
Is that a good approach?
It's popular, but Ousterhout has some reservations about it.
Okay.
He's concerned that it can lead to a very tactical approach to programming,
Okay.
where you're so focused on passing those individual tests
Right.
that you might lose sight of the overall design.
So instead of building a house with a blueprint, you're just like adding rooms randomly
Yes.
and hoping it'll all fit together.
Exactly, and that can lead to a messy system.
Right.
So he believes that TDD is most helpful when fixing bugs.
Okay.
Because if you write a test specifically for the bug before you fix it,
Right.
you can ensure that you've actually solved the root cause.
Oh, that's a good point.
Right.
You're basically guaranteeing that the bug is gone. It's not going to come back.
Exactly. It's a much more targeted approach to bug fixing.
Okay, so TDD, good in certain cases,
Yes.
but, use it strategically.
Strategically.
Okay. This is all fascinating stuff.
It is.
I feel like we've covered a lot of ground.
Yeah.
Deep modules, information hiding,
Yeah.
comments, testing. Oh, have we touched on everything from the book at this point?
Almost. We've got a few more nuggets of wisdom to unpack.
Okay, I'm ready for more. Hit me.
All right. So one thing that Ousterhout brings up is this idea of getters and setters,
Oh, wow.
which is a really common pattern in object-oriented programming.
Getters and setters, yeah, I've seen those used all the time.
Yeah.
But I'm not sure I totally get, what's the point?
Yeah, so they're basically about controlling access to the internal data of an object.
Okay.
So a getter, it lets you retrieve the value of a private variable, and a setter lets you change it.
Okay, so it's like having a security guard, right?
Yeah,
For your object's data.
right.
They get to decide who can see what and who can modify what.
Exactly.
Okay. But couldn't you just achieve the same thing by making those variables public in the first place?
You could, but then you'd be violating that principle of information hiding.
Right. Right. You'd be
Like that.
exposing all the internals.
Exactly. And so Ousterhout's point is that while getters and setters can be helpful in certain situations,
Okay.
it's better to avoid just directly exposing variables.
Okay. So it's about thinking more strategically and finding ways to encapsulate the data and the behavior within the object itself.
Exactly.
Okay. So this all makes sense.
Yeah.
But it feels like there's this tension, right?
Yeah.
Between wanting to keep things simple,
Right.
but also dealing with the inevitable complexity that comes up
Absolutely.
in real world systems, right?
Yeah.
So how do we strike that balance?
So Ousterhout says that the key is to always be looking for ways to simplify,
Okay.
even when things get complicated.
So not pretending that complexity doesn't exist,
Right.
but actively trying to minimize it.
Exactly. And he introduces this concept of defining errors out of existence, which I think is really fascinating.
Wait, defining errors out of existence?
Yeah.
How do you just make errors disappear?
It's not really about making errors impossible,
Okay.
but it's more about rethinking how you handle them.
Okay.
So he argues that what we often perceive as errors
Yeah.
are actually just special cases that we haven't accounted for in our design.
So instead of treating this as an error, we just build it into the system
Exactly.
as a normal occurrence.
Exactly. And he gives a great example from the Java string class.
Oh, okay.
Do you remember the infamous substring method?
Substring, yeah.
So in Java, if you use the substring method with an index that's beyond the length of the string,
Okay.
it'll throw an exception.
Which seems reasonable, right?
You'd think so, right?
You're trying to access something that doesn't exist.
Exactly.
It should throw an error.
But Ousterhout argues this is a case where the error could have been defined out of existence.
Oh, okay. I'm intrigued. How would you do that?
So by changing what the substring method does in that situation,
Okay.
instead of throwing an error, it could just return the substring from the starting index to the end of the string.
Oh, okay.
Right, so you're basically just redefining the behavior to handle that edge case.
Right. So it's still like well-defined behavior.
Right, exactly.
But you're not throwing this like exception that then.
Exactly. It simplifies the code, makes it less error-prone.
Yeah. Okay, but are there situations where you can't just like define errors out of existence? Like what if something actually goes wrong? Like,
Yeah.
a network connection fails.
You're right.
Or a hard drive crashes.
Yeah, absolutely. Some errors you just can't wish away.
Right.
But he has strategies for managing complexity even in those cases.
Like, what are those strategies?
So one is exception masking.
Reception masking.
Yeah, and essentially this is where you handle an exception at a low level so the higher level components don't need to know about it.
So you're like sweeping the problem under the rug.
Not exactly. It's more about handling it in a way that's appropriate for that layer of the system.
Okay.
So he uses the example of NFS, the network file system.
Right. For sharing files over a network.
Right, exactly.
Like, what's the issue there?
So if the NFS server crashes, the client applications can hang indefinitely, waiting for it to come back online.
Oh, yeah, I've experienced that. That's so frustrating.
It is, and a lot of people suggested that NFS should throw an exception in that case.
Okay.
So the client application would know what was going on.
Yeah, that seems like a reasonable solution.
Yeah.
At least you get some feedback.
You would think, but Ousterhout argues that throwing an exception would actually make things worse.
Really? Why is that?
Because if the client application loses access to its files,
Right.
there's not much it can do, right?
Well.
Retrying will probably just lead to another hang.
Right.
And aborting the application is disruptive to the user.
So you're kind of stuck.
Yes, stuck between a rock and a hard place.
Yeah.
So the solution is for NFS to just mask the exception.
Okay.
Keep retrying in the background.
Okay.
Until the server is back up, and then the client applications are none the wiser.
Oh, wow. So they're just like blissfully unaware.
Yeah, they just keep working as if nothing happened.
Okay, so exception masking, it's about like picking your battles, right?
Yeah, you have to choose wisely. It's about finding that balance.
Yeah.
Between handling errors gracefully without,
Right.
burdening the higher level components with complexity.
Okay, got it. Now, are there other techniques for managing exception complexity?
Yeah, so another one is exception aggregation.
Okay, exception aggregation. Tell me about that one.
So this is about handling multiple exceptions with a single piece of code
Okay.
instead of having, separate handlers for each one.
So it's like having a general emergency response team that can handle all sorts of situations.
Exactly.
Versus like needing a specialist for every single type of incident.
Exactly. And so he gives this example from web servers.
Okay.
So when a web server receives a request, it often needs to pull parameters from the URL, right?
Right.
And if a required parameter is missing, it'll throw an exception.
That makes sense. You need all the information.
You do.
To process it.
But if you handle each missing parameter exception separately, you end up with all this repetitive code.
Yeah, because they're all basically the same error.
Exactly. So a better approach is to aggregate those exceptions.
Okay.
Let them bubble up to a higher level where they can all be handled by a single piece of code.
So you're like centralizing the error handling.
Exactly.
Making the code cleaner.
Exactly. You can even take it a step further and aggregate all the exceptions that result in the same response.
Oh, interesting.
Right.
Right.
So, for example, a missing parameter, an incorrect format, a user lacking permission.
Right.
All those could be handled by one piece of code.
Right. That just sends back like the appropriate error.
Exactly.
Okay.
So it's about finding ways to consolidate that logic.
Right.
Make it more robust and easier to manage.
Okay, this is great. We're writing cleaner code.
Yeah.
More maintainable code. But I have a confession.
Okay.
I sometimes feel like stuck in a rut. Just churning out code.
Yeah.
Not thinking about the bigger picture.
Right.
Any tips for breaking out of that tactical mindset
Absolutely.
and becoming like a more strategic programmer?
So Ousterhout suggests this principle of design it twice.
Design it twice.
Okay. Yeah.
Doesn't that mean like twice the work?
It might take a little bit more time up front.
Okay.
But it's going to save you a ton of time and headaches in the long run.
Okay.
So force yourself to come up with at least 2 different design approaches before you settle on one.
Oh, okay. So you're really like exploring the possibilities before you commit.
Exploring, exactly.
What are the benefits of that?
So there's a few. First of all, it forces you to think more deeply about the problem.
Okay.
Consider those trade-offs.
You're not just going with your first instinct.
Right.
You're actually evaluating it.
Exactly. It also helps you avoid getting trapped in a local optimum.
Local optimum.
Yeah, so this is like when you find a solution that seems good, but there might be a much better solution out there
Right.
that you just missed because you were so focused on your current approach.
Ah, okay, got it. So design it twice.
Right.
Helps you like break out of that
Yeah.
tunnel vision.
Exactly.
Okay, I like that. And third,
It can help you identify potential problems early on.
okay, because when you compare different designs, you can see where each one like shines and where it falls short.
Exactly. It helps you avoid costly mistakes later.
Design it twice. That's my new mantra.
There you go.
Okay. So how do we actually like generate these multiple designs?
So Ousterhout recommends brainstorming with others.
Okay. Get those
It-
different perspectives.
With a perspective?
See what emerges.
Yeah, even if you're working alone, you can try to just come up with solutions from different angles.
Oh, okay. So like what would a security expert do?
Exactly.
What would a performance guru do?
Exactly. Another technique is to work backwards from the desired outcome.
Oh, interesting.
Right. So start with the end goal in mind.
Okay.
and then figure out the steps to get there.
That's a cool idea.
Yeah.
Okay. So we talked about like designing things twice. This all sounds great.
Yeah.
But there's one thing I've always struggled with, and that's naming things.
Oh, yeah.
Any advice for picking good names for, variables, methods, classes, all that stuff?
Naming things is one of the hardest things in computer science.
Oh, tell me about it.
It is.
It's like I feel like I spend more time thinking of names than writing code sometimes.
You can feel that way.
Okay, so Ousterhout, does he have any wisdom on this?
He does. He stresses this idea of choosing names that are precise, unambiguous, and intuitive.
Okay, so it's not just about finding a name that's like vaguely related.
Right.
It's about really capturing what that thing is.
Capturing the essence, exactly.
Okay. So what are some of the principles that we can keep in mind when we're doing that?
Okay, so first of all, avoid vague names.
Vague names, okay.
Right. So if a name is so broad that it can mean many things, it doesn't provide much information, and it's more likely to be used incorrectly.
So like instead of data,
Right.
call it customer data or order data.
Exactly. Be specific.
Okay, cool. What else?
Second, use names that are consistent with the level of abstraction.
Okay.
Right. So high-level concepts get high-level names.
Okay.
Low-level details get low-level names.
Got it. Don't mix them up.
Don't mix exactly. It just creates confusion.
Okay.
And third, think about it from the reader's perspective.
Okay, yeah. Imagine you're seeing this code for the first time.
Right.
Would that name make sense to you?
Exactly. And you also want to be mindful of the terminology used in your specific domain,
Okay.
right? So if you're working on a web app,
Yeah.
stick to terms like request and response.
Right, things that people in that world would understand.
Exactly.
That-
So again, this reader-centric approach is crucial.
Cool. Okay, and speaking of making code understandable, Ousterhout, he has some pretty strong opinions about comments. Didn't we already talk about comments?
We did, but he specifically recommends writing them first.
Seriously.
Yes.
Like before writing any code.
before you write any code.
I know we touched on this, but it still feels so strange to me.
I know, it sounds counterintuitive.
It does.
But think about it. It forces you to think about the design before you get bogged down in all those details.
So, like we said, it's like a blueprint.
It's like a blueprint.
Okay.
And it can actually help you expose potential complexity issues early on.
Because if you can't explain it clearly in a comment, the design itself might be the problem.
Exactly.
Okay.
So Ousterhout believes that this approach leads to better documentation and a better design.
Okay, so if you're writing the comments before the code, what are you commenting on?
So he suggests starting with what he calls interface comments.
Interface comments.
Yeah, so comments that describe the public methods and variables of a class.
Okay, so you're defining like the contract
Exactly.
between this class and like its clients.
And-
The inputs, the outputs, the expected behavior.
Exactly. And then once those interface comments are done, you can move on to the implementation comments.
Okay, so like different levels.
Different levels of documentation.
Okay.
So you have the high-level overview,
Right.
and then you have the nitty-gritty details.
Okay, that makes a lot of sense. This is all incredibly helpful.
Good.
But even with all these techniques, software can still be, complex.
It can.
Are there any other like tools or approaches that can help us manage that?
Yeah, so Ousterhout actually has a whole chapter
Okay.
on different software development paradigms.
Oh, okay. So like objects-oriented, functional, agile.
Exactly. And he challenges us to really look at each paradigm and ask, Does it actually help minimize complexity in large software systems?
So it's about like making informed choices,
Yes,
not just blindly following trends.
exactly.
Okay. And does he have like strong opinions about any of the specific paradigms?
He does. So, for example, he's a big proponent of unit testing, which we've talked about.
Right. Isolating and testing individual pieces of code.
Exactly.
Okay. But is he a fan of test-driven development?
He's not as enthusiastic about test-driven development.
Really?
Yeah.
I thought that was like considered best practice by a lot of developers.
It is very popular.
Yeah.
But Ousterhout's concern is that TDD can lead to that very tactical approach
Yeah.
where you're so focused on passing those individual tests that you lose sight of the design.
Right. It's like building the house without a blueprint.
Exactly.
So adding rooms randomly.
Exactly. And that can result in a very messy system.
Right.
He thinks TDD is particularly useful when fixing bugs
Okay.
because writing that test for the bug before you fix it really ensures you've addressed the root cause.
Right. You're not just like patching over it.
Exactly.
Okay. Got it. So TDD, good for that.
Yes.
What about design patterns?
So he has some interesting points about design patterns as well.
Yeah. What are those?
He believes they can be powerful tools, but he cautions against overusing them.
Okay. So don't try to like cram a design pattern into every situation.
Exactly.
Sometimes simple is better.
Right. And he also warns against thinking that more design patterns automatically equals a better design.
Okay, yeah, sometimes the simplest solution is the best, even if it doesn't use a fancy pattern.
Exactly. It's about being pragmatic and choosing the right tool for the job.
Right.
Not just showing off how many design patterns you know.
Right, okay, that's a good point. So this recurring theme of like power versus complexity.
Yes.
Right.
It comes up again and again.
Use the powerful tools effectively,
Yeah.
but don't let them like dictate your decisions.
Exactly.
Okay, cool. This is all really insightful stuff.
Good.
But sometimes performance is just as important as simplicity.
It is.
Right. So how do we design systems that are like both easy to understand and like blazingly fast?
Yeah. Great question. So Ousterhout believes that clean, simple code is often naturally efficient.
Wait, really?
Yeah.
I always thought that like to get the performance, you had to make the code more complex.
That's a common misconception, and
Yeah.
he actually argues that complex code tends to be slow because it's doing all this extra work,
Right.
repeating things unnecessarily.
Right.
So if you just write clean, simple code, your system will probably be fast enough without even trying.
So simplicity is like a shortcut to performance.
In many cases, yes. But if you do need to optimize for performance,
Okay.
he does have some strategies.
Okay, I'm listening. Tell me more.
So first, profile the system to find the actual performance bottlenecks.
Okay.
Don't waste time optimizing code that isn't actually slowing things down.
Be data-driven, don't just assume.
Exactly. And once you've found the bottleneck, focus on simplifying that critical path,
Okay.
the parts of the code that have the biggest impact on performance.
Okay, so make the stuff that gets used all the time
Right.
as efficient as possible.
Exactly. And he gives a great example from the RAM Cloud project.
RAM Cloud.
Yeah, where they achieved a significant speed boost by simplifying the code for allocating memory buffers.
Okay, so they were using these buffers all over the place,
They were
and they realized, oh, this is actually
critical.
to our performance.
Okay, so what did they do?
So they took a close look at that code,
Okay.
and they found that it was just full of special cases
Oh, geez.
and redundant checks, which just added unnecessary overhead.
So complexity was the enemy of performance in that case.
Exactly. And so they refactored the code,
Okay.
eliminated those unnecessary checks,
All right.
streamlined the most common cases.
And what was the result?
They got a 2x speed up
Wow.
for the most common operations.
Just from simplifying the code.
Exactly, which highlights one of Ousterhout's main points.
Yeah.
Clean design and performance often go hand in hand.
Okay, cool. So you don't have to choose one over the other.
Exactly.
You can have both.
You can have both.
Okay, that's encouraging. So, I have another confession.
I get really distracted by shiny new tools and technologies.
It's easy to do.
It is. So any advice on like resisting that temptation
Yeah.
and really focusing on like building those solid maintainable systems?
So Ousterhout encourages us to be skeptical of
Okay.
any new paradigm. Challenge, does it really help minimize complexity in large systems?
So don't just jump on the bandwagon.
Right.
Really think about it.
But think critically.
Okay. And he also cautions against thinking that new is always better.
He does. Sometimes those old tried and true methods are still the best.
Okay, so again, it's about like being thoughtful
Yeah,
and making the right choice for the situation.
exactly.
All right. This is all making a lot of sense. Sometimes it feels like there's so many things to consider when designing software.
There are.
Right. Any tips for like keeping it all straight
Yeah.
and making sure we're not forgetting anything?
So Ousterhout actually provides a nice little summary of key design principles at the end of the book.
Oh, like a cheat sheet.
Kind of, yeah.
Okay, what are some of the highlights?
So number one, he reiterates that minimizing complexity is the primary goal of software design.
We've talked about that a lot.
A lot, right? And he emphasizes that complexity is incremental.
Okay.
Right. Those seemingly small design choices can really snowball
Got me.
to huge problems later.
You got to sweat the small stuff.
You do. Every decision matters.
Okay.
He also points out that good design is more about minimizing dependencies
Oh, yeah.
than maximizing reuse.
Oh, interesting. I thought those two went together.
You would think so, but they don't always. Sometimes trying to maximize reuse just adds unnecessary dependencies.
Okay, so it's a balancing act.
It is.
Okay.
He also emphasizes designing modules that are deep, hiding a lot of complexity behind simple interfaces.
Like that Unix I/O.
Exactly.
Okay.
And he reminds us that information hiding is essential for minimizing dependencies,
Okay.
making systems easier to work with.
Each module minds its own business.
Exactly.
Okay.
And he reiterates the importance of defining errors out of existence whenever possible.
We talked about that.
We did.
Okay.
And designing those systems to handle those special cases gracefully
Okay.
without throwing exception.
Flexibility, resilience, key.
Yes. And of course, choosing good names,
Yeah.
precise, unambiguous, and intuitive.
Naming things is hard but important.
It is.
Okay.
And he stresses writing comments first as part of the design process.
Right, like we said, exposing those potential complexity issues
Exact.
Like-
Early on.
early on.
Okay.
And finally, consistency is crucial
Consistency. Okay.
for reducing cognitive load and making systems easier to
Yeah,
understand.
establish those conventions.
Yeah.
Stick to them.
Stick to them. It applies to everything.
Mm-hmm.
Naming, coding style, error handling, documentation.
So be consistent.
Be consistent.
Okay, cool. This is all great advice.
Good. Okay.
Now one last thing. Ousterhout, he mentions these red flags, right?
He does.
Warning signs that there might be design problems.
Can you give us a rundown of some of the big ones to watch out for?
Absolutely. He has a nice little list of red flags at the end of the book.
Perfect. Let's hear it.
So number one is shallow modules.
Okay. Deep modules, good. Shallow modules, bad.
Exactly. They don't help much with complexity management.
Got it. What else?
Information leakage.
Oh, yeah. That's where the same knowledge is duplicated
Right.
across different parts of the system.
Exactly. Like those classes for receiving and parsing HTTP requests.
Yep. Okay.
What else?
Temporal decomposition.
Okay.
Uh-huh.
That's where the system is structured based on like the order of events
Yes.
rather than the underlying functionality.
Right. You're thinking too much about the steps rather than the core actions.
Okay.
Another one is pass-through variables.
Pass-through variables, what are those?
So this is when data is passed through multiple layers of a system without actually being used
Oh.
or modified.
It's like a package being passed from person to person.
Yeah.
No one's opening it.
Right.
Exactly. Nobody needs it, but it keeps getting passed along.
Okay.
What else? Unnecessary dependencies.
Okay, so modules that rely on each other
Yeah.
more than they need to.
More than they should.
Okay.
So you make a change in one place, you have to make changes all over the place.
Right. Got it. Okay.
Another one is overly general purpose classes.
Wait, I thought we said general purpose was good.
We did, but there's a balance, right?
Right.
If a class is so general that it's hard to use for its intended purpose, that's a problem.
So it's about finding that sweet spot.
Finding the sweet spot, exactly.
Okay.
Another one is comments that repeat the code.
Oh, yeah, that's just like rephrasing what the code's doing.
Exactly.
Okay.
And of course, code that's just non-obvious
Yeah.
or hard to understand.
Okay, if I have to like really think hard to figure out what the code is doing,
Right.
that's a bad sign.
Exactly.
Okay. And what about inconsistency?
Inconsistent behavior is another one.
Yeah, like similar actions are done differently in different parts of the system.
Exactly.
That's annoying.
It is. It means you have to relearn how things work
Right.
every time you move to a different part of the code base.
Yeah. It's super frustrating.
It is. And that was just a few of the red flags that he highlights.
Okay, so this is incredibly helpful. I feel like I've gotten a crash course in better software design.
I'm glad to hear it.
Okay, cool.
And remember, the key is to look for those ways to simplify to reduce complexity.
Right.
Make your systems easier to work with.
Easier to understand, easier to maintain.
Exactly.
Hopefully faster.
Faster, more efficient, yes.
Okay, cool. This has been an amazing deep dive.
It has.
But before we wrap up,
Yeah,
I have
yeah.
one last question for you. So, Ousterhout's book is about software design.
Yeah,
But we've talked about how a lot of these principles can apply to other systems.
they do.
Right. Can you give us some examples of how these principles could be used outside of software?
Yeah, absolutely. So modularity, information hiding, consistency,
Okay.
these ideas can be applied to all sorts of systems. Businesses, organizations, even cities.
It's really about like taking a step back, right?
It is.
Thinking about these fundamental principles.
Exactly.
No matter what you're
Yeah, but,
designing.
I really feel like, just looking around, observing the world with these principles in mind,
Yeah.
you start to see, oh, wow, this could be designed better.
You do.
This website could be designed better. This organization can be structured better.
Absolutely.
It's
Warren.
really eye-opening.
It is. It makes you think differently about the world.
Yeah, absolutely. Well, this has been a fantastic deep dive.
It has.
Is there anything else you want to share with our listener before we wrap things up completely?
Yeah. I think one final thought is that, Ousterhout's book, it provides this framework for thinking about design.
Okay.
But it's not like a rigid set of rules, right?
Right. It's more about understanding the principles.
And then applying them in an intelligent way
Exactly.
to your situation.
And the more you understand those principles, the better you'll be at making those design decisions and creating systems that are both powerful and beautiful.
And a lot less complex.
And a lot less complex.
I think we've given our listener plenty to think about.
I think so too.
So if you're listening out there
Yeah.
and you're looking for ways to, create systems that are easier to understand, easier to maintain, easier to evolve,
Yeah.
I highly recommend checking out John Ousterhout's work.
It's a really valuable resource for anyone who builds systems,
Yeah.
manages systems, whether it's software, teams, or even your to-do list.
Yeah, it's really, it's such a powerful book. So we hope this deep dive gave you a good, solid foundation in Ousterhout's key principles.
Yeah.
And now go out there and build some amazing things
Go build amazing things.
that are not overly complex.
Exactly. Keep it simple.
Yeah. All right. Well, thanks again for joining me.
It was my pleasure.
And thanks to all of our listeners for tuning in. Until next time, happy designing.